Our third lesson for Chapter 6 is on solving systems by elimination. So it will be another algebraic way to figure out if your solution is an ordered pair, no solution, or infinite solutions. So date goes over there. We'll get started. All right, so we have some steps to write down in our notes, and I will explain the steps when we do a few of these examples together. But the elimination method, what you're going to do is pick one variable to eliminate. So you'll look at the problem and say, I want to eliminate the x's or the y's. It doesn't matter which one you pick. Usually one of them looks easier. Then you're going to use multiplication. We're going to multiply the equation, or possibly both of them, by a number so that they have the same positive and negative variable. That will make sense when we see an example. Then you're ready to add the equations together, and then you can solve. This step with the multiplication may or may not be necessary, so we'll kind of show examples where it is and where it is not. Okay, so our first system looks like this. What we're going to do is we're going to think about adding these two equations together. So it's a vertical addition that happens. So we add the x's, we add the y's, your equal sign comes down, and you add the numbers on the end. If you notice, everything is lined up vertically. That's how we need this to work for elimination. What we're looking for, if you look at the x's right now and you add them, x plus 5x is 6x. So nothing cancels there. So we move on and we look at the y's. Negative 2y plus 2y. This is what we want it to look like so that we can eliminate the y's. A negative 2y plus a positive 2y equals 0. So our goal when we do elimination is to get your equations to look like this. This example already has it set up. So when you add this left to right, x plus 5x is 6x. Negative 2y plus a 2y is 0, cancels out. Bring down your equal sign, and negative 19 plus 1 is a negative 18. After you do that step of adding the equations together, you're left with a one-step equation. So we divide both sides by 6, and x equals negative 3. Now, you can see that we're getting an x. Remember, our possible outcomes is we can get your lines could cross, so you get an ordered pair, or maybe it's a no solution, parallel lines, or an infinite solution, the same line. So right now we can see that we are getting an ordered pair. So we've got the x. To get the y, all you have to do is plug it back into one of the top equations, whichever one looks easier. Maybe I'll pick the top one. So I'm going to take this negative 3, plug it into this top equation. So I'll just rewrite it. X minus 2y equals negative 19. Well, now that I know that x is a negative 3, I'm going to put a negative 3 in for the x. And we're going to solve this equation. We'll add 3 to both sides. So negative 2y is equal to a negative 16. And then we divide both sides by negative 2. And we get y is equal to 8. So our solution, our ordered pair, negative 3, 8. So our two lines will cross at that point. All right, here's our second example. Again, elimination, we want to add the equations together. So look at the x's, look at the y's. Well, if I look at the x's, 2x and a negative x, those do not cancel each other out. You would want a 2x and a negative 2x. The y's, let's check out the y's. You've got a y and a 3y. These do not cancel each other out also. If this was a negative 3y on the top, then we could cancel those. So what you want to do is just pick either the x or the y to eliminate. I'm going to go ahead and pick the x. So if we focus on just the x right here, you've got a 2x and a negative x. We want this to be a negative 2x. So what we do is we basically manipulate the equation. We bring in multiplication. If I multiply that whole equation by a 2, that's going to give me that negative 2x that I need. So the top equation doesn't change. 2x plus y equals 3. Now I'm going to distribute this 2 to every single term in the equation. It's going to give us negative 2x plus 6y equals negative 24. So then we go to add these two equations together. 2x plus a negative 2x, that cancels out. That's why we brought in the multiplication, so that that would happen. Y plus 6y is 7y, and 3 plus a negative 24 is a negative 21. So there's that one-step equation to solve. We'll get y is equal to negative 3. Now to get the x, we're just going to plug that y in to one of the equations up here, whichever one looks easier. Maybe I'll pick that top one. 2x plus y equals 3. Well, now we know that this y, we can plug in for that y. So 2x plus the negative 3 is the same thing as minus 3 equals 3. And then we go ahead and solve for y. 2y equals 6, divide both sides by 2, and y is equal to 3. So our ordered pair is, did you guys see what I did? So this x, when I rewrote it, should have still been an x, which means this is still an x, which means x is equal to 3. So we have 3 comma negative 3. All right, next example. Elimination, we want to add the equations together, look at the x's, look at the y's. Now, looking at the x's, 6x and 4x don't cancel out, so I make sure I check out the y's also. Negative 3y, negative 2y doesn't cancel. So I'm just going to pick one of these to focus on. Maybe I'll focus on the y's this time. So I want those to cancel. I can multiply both equations by different numbers to get those to be the same thing. So let me show you what I'm going to do. I'm going to multiply the top equation by a 2. That's going to give me 12x minus 6y equals 2. So I multiplied everything by that 2. Now the bottom equation, I don't want to multiply by a 2. I want this down here, this negative 2y, I want that to be a positive 6y over here. So what do I multiply it by to get it to be a positive 6y? A negative 3. So you'll see how this works out. You have negative 3 times 4x is negative 12x. Then you have negative 3 times a negative 2 is positive 6y equals negative 3 times 7 is negative 21. Now we can add these equations together. So our goal was to eliminate the y's. If you look at the y's, you have a negative 6y and a positive 6y, so those cancel each other out. But when we go to add the x's, we notice that we have a 12x plus a negative 12x. So they actually cancel out also. The equal sign comes down. You got 2 plus a negative 21 is negative 19. So what are we going to have on the left side of our equal sign over here? Well, if everything has canceled, technically it all equals 0, so let's just put a 0 in there. So we've eliminated the x's and the y's, and we have 0 equals 19. So these two lines do not cross at a single point. It's either our all solution or no solution. Because this is false, 0 does not equal negative 19. That means that solutions do not exist, so there's no solution. All right, last one from the intro video. Look at the x's, look at the y's, see if anything cancels. Nothing does right now. Pick which one you want to eliminate. I'm going to focus on the x's. Those are smaller numbers, so that would be a good one. So you have a 4 and a negative 3. We're going to use multiplication to get those up to the same number. So 4 and 3 will both multiply up to 12. So let's get these up to 12 x's. So the first one I'm going to multiply by, let me see if I can, there we go, I can erase that. Let's multiply the top one by 3. That's going to give us 12x minus 48y equals 12. Now the bottom equation, we want that negative 3 to multiply up to a negative 12, so we can multiply it by 4. 4 times negative 3x is negative 12x. 4 times 12y is 48y. And 4 times negative 3 is negative 12. All right, so we can eliminate now. 12x plus a negative 12x cancels out. That's what we intended to happen. Now if you look at the y's, negative 48y plus 48y, well, that's going to cancel also. So if everything's canceling on one side, let's go ahead and leave a 0 in its spot. Bring down your equal sign. And now we have 12 plus a negative 12. Well, that cancels also. 12 plus negative 12 is 0. So we did not get an ordered pair in x and a y, so it's got to be your no solution or infinite solutions. And because 0 does equal 0, it's true, this is going to be your infinite solution example.